Hi guys, I know we were supposed to be reviewing trigonometry, but I just saw it somewhere in the textbook and I thought it was a cool thing for today, so here we go. I don't think you've ever learned this before. You might have seen it, but because it's all patterns and you've done a lot of patterns in mathematics, I think this is a good review. All right, let's start with something like this. X plus y. I want to square it. Well, can you do it? I hope everybody can do it. I know that this is x squared plus 2xy plus y squared. If you are questioning this, well, think about x plus y times x plus y. If you want to do it the long way, go for it, and you'll get this as your answer. All right, what about if I want to do x plus y to the power of 3? Some of you have great memory, and some of you will remember right away that it is, well, I am not one of those with the great memory, so I would have to take x plus y. Well, we've already done x plus y squared, so I could say x squared plus 2xy plus y squared, and then I could do all that fun stuff. And I am losing my patience, so here we go. You can do this after. But what if I challenge you a little bit more and I say, let's raise it to the power of 4? Well, no, I am not going to do this. You can do it if you have nothing better to do. Now, what if I say I want you to go even farther, raise it to the power of 5. Yes, that would be a lot of work. So that's why we are going to learn a very nice shortcut. There's a beautiful triangle that consists of many patterns. And I'm sure you've seen this before. It looks like this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and we could keep going. If you've seen it before, I hope you remember that it's called Pascal's triangle. Pascal was a French mathematician. He was not the one that figured out this pattern, but for whatever reason, it was named after him. This was already studied much earlier than Pascal. Pascal lived in like 17th century, and this was already studied in 10th century in different places. However, how does this work with the examples that I wanted you to do at the beginning? Well, let's see. If I have x plus y squared, I've done this. I knew the answer right away. X squared plus 2xy plus y squared. If I asked you, how does this relate to our Pascal triangle? If you are quick at looking at the patterns, you would notice that I have 1 here. Here's the 1. I have 2 here. This is the 2. And I have 1 here, this is the 1. Now, how does this work with the variables? Because this is the second, well, depends. Sometimes the rows are counted differently, but this is corresponding. This is to the second power, so we square the first variable. Notice how this is to the first power. Notice how there's no x, but you can think about the x as being to the 0 power. And then looking at our y's, this is the y squared, this is y to the 1 power, and this is y to the 0 power. That's why it's not there. Let's see, I did not want to do x plus y to the 3rd power because I said it would be a lot of work. But now if I follow my pattern, this is going to be 1x to the power of 3 plus 3x squared y plus 3x y to the 2nd power plus y to the 3rd power. So let's take a look. This is the 1, this is the 3, this is the 3, this is the 1. As far as power, we are starting with the third power, second power, first power, 0 power. That's why x doesn't exist right in here. And as for the y's, y to the third, y to the second, y to the first, y to the 0. Well, knowing this pattern, I can even go a little bit farther. If somebody asks me what is x plus y to the power of 4, I would say, well, x to the power of 4 plus 4x to the power of 3, y to the power of 1, plus 6x to the power of 2, y to the power of 2, plus 4x. X value is going down, so x to the power of 1, y to the power of 3, plus 1, y to the power of 4. Here we go. I hope I got this right. And we could continue, we could follow the same pattern, and we could figure out whatever power we would like. All right, now let's see. I didn't say this. I hope you figured it out how this triangle is formed. Where is this 3 coming from? This 3 comes from adding those two values. The same thing here. Well, if I want to figure out what this 6 is because I took those two numbers and added them together. This 10, it's the 4 and 6. So you take the two numbers above, add them together, and you will get your answer. Now, what would happen if I had a negative sign? So let's see. I am going to use just a random example like this. I want us to solve what is happening if I have 3x minus 2 and I want to raise it to the power of 4. So the first thing that we are going to do is we are going to decide what row are we working with from our Pascal's triangle. And I am looking at the row and I see that because this is to the 4th power, I have 1, 4, 6, 4, and 1. Well, trust me, take a look at your Pascal triangle from your notes and we'll follow that. Okay, the first thing that we are going to do is we are going to take the first term and we are going to raise it to the power of 4. Then we are going to take our coefficient, so this is from our Pascal's triangle. Next, we are going to take 3x, and instead of the power of 4, we are going to go down 1 power, and we are going to multiply it by negative 2. Next, the coefficient is 6. Again, I am taking that from the Pascal's triangle. I am going to multiply this by 3x to the power of 2, and now negative 2. This was to the power of 1, so now this is to the power of 2. Next, I am going to have plus, again, from the Pascal's triangle, I see that the coefficient is 4. And then I am going to have 3x to the power of 1 times negative 2 to the power of 3. And last term that I am going to fit right in here, I am going to have 1. That's from the Pascal's triangle. 3x is going to be raised to the power of 0, which is gone. And then negative 2 is going to be raised to the power of 4. All right, now I got it all. I just have to clean it up. If I do 3 to the power of 4, everybody knows that that is 81. X to the power of 4 plus, now here I have to do 3 to the power of 3 first, and then I need to multiply it by 4, and then I need to multiply it by negative 2. So that is going to give me negative 216 x to the power of 3. Now, I should have paid attention to the sign, so I wouldn't write it like this, but that's okay. I will clean it up after. I see that this negative sign is going to be raised to the power of 2, so that is going to be gone. So what I have is 6 times 9 times 2, not times 2, times 4. Well, that's easy fixed. I will multiply it by 2 again. So that's plus 216x squared. This one, I know that this is negative 8. So if I take 8 times 12, that is going to give me 96. So I have negative 96. And then this one, I have negative 2 to the power of 4. That is positive 16. All right, it looks like I have my answer. So this is going to be 81x to the power of 4 minus 216x to the power of 3 plus 216x squared minus 96x plus 16. I want you to see what happens with the signs. Positive, negative, positive, negative, positive. This is the pattern that will be followed if you have a negative sign right there. All right, we'll do one more example. And this example is going to be a little bit, a little bit different. So notice that we started with an expression and we expanded it. Now, what if we want to go the other way? What if I give you something like this? X to the power of 4 plus 4x to the power of 3 plus 6x squared plus 4x plus 1. And what I want you to do is I want you to write this as something to appropriate power. Let's think about this for a second. Take a look at the Pascal triangle. Well, this one is actually fairly not complicated example because this is 1, and then I see that the powers just go nicely down. So if you look at your Pascal triangle, that is that row that has the following numbers, right? And I want you to see how those numbers match. So, and then all of those signs are positive, so I know that this is plus x plus 1 to the power of 4. Done and done. All right, one more example, and that example is going to be a little bit more difficult, but not much more difficult. And I will do the same thing if I want to factor. So example 3 is going to be 8x to the power of 3 minus 12x squared plus 6x minus 1. So the first thing you should think of is this is to the power of 3. So which row from the Pascal triangle are you going to use? Well, because it's the power of 3, I am going to use the row that has the following numbers. And now I don't want the 8. I want some number that can be raised to the power of 3 that is equivalent to 8. And we do know that this would be the same thing that 2x to the power of 3. Now, if I write this like this, let's see if this works. Because this number is just 1, I will have 1, and I would raise it to the power of 3. And notice I did put the negative sign because I have plus, minus, plus, minus. Here we go. All right, I will give you some assignment to practice.